All right, so yesterday when we talked about trig graphs, we introduced ourselves to two graphs, sine and cosine. And we talked about something called amplitude, which is what this A stands for in front of each of the functions. We talked about how amplitude was the height of the graph, and it was figured out by the difference between the max and the min values divided by 2. So, for example, our regular sine graph, and cosine for that matter, has an amplitude of 1. That's the height from what we call the midline. So now we have this new term where it's called the frequency, and it's denoted by this b value on the x. Frequency is the number of complete cycles from 0 to 2 pi. So if we look at this picture over here that I sketched of y equals sine of x, this is one full sine curve that, if it was y equals sine x, would occur from 0 to 2 pi. What happens if I say that two sine curves are happening from 0 to 2 pi instead? So maybe in another color, I'll add another. So let's say this is all occurring between 0 and 2 pi. So since two complete cycles occurred between 0 and 2 pi, the frequency is then 2. So then there's another term that's related to the frequency, which is period, which is the horizontal length of one cycle. So how much space do you need to see the entire curve on your graph? So really what I'm asking is, if this is one full sine curve here in navy blue, how many units does it take to see that? So from 0 to 2 pi, two of them occurred. So then from 0 to pi, one occurs. So another way of thinking about that is, if two curves are occurring between 0 and 2 pi, then one curve must occur between 0 and pi. So what we just talked about was how you find the period. So you take 2 pi and you divide it by the frequency. So in this first section here, we're just looking at 4 different functions, and I want to find the amplitude, frequency, and period of each of the following. So for example, in A, the amplitude is 3. And remember, this is always going to be a positive value because it's a distance. The frequency is 2. So if I want to know what the period is of this graph, it's 2 pi divided by the frequency, which is 2, which is then pi. So what this is telling me is that on this graph with an amplitude of 3, there's two full sine curves occurring between 0 and 2 pi. So if I want to see just one of the curves, it's only pi units. Okay, over here at B, again, make sure your amplitude is positive. It's not going to be negative 2. That just tells me there's been a reflection in the x-axis. My frequency is 1/2. So the period will be 2 pi divided by 1/2, which is the same thing as multiplying by 2, so 4 pi. Okay, got a couple more examples here. Y equals 1/2 cosine 4x, amplitude's 1/2. Frequency is 4. So the period must be 2 pi divided by 4, which simplifies to pi over 2. And lastly, amplitude is 5, because that's the coefficient here, and we're always taking the positive. Frequency is 1/4. And the period will be 2 pi divided by 1/4, or 8 pi. It's a nice little warm-up there. So now we're going to look at graphing this. So you see, I want to graph the function y equals 3 sine 2x. So first let's list some information about this graph. The amplitude is 3. So that means sine, instead of oscillating between 1 and -1, it's going to oscillate between 3 and -3. The frequency is 2, so that means between 0 and 2 pi, you will see 2 full sine curves. And the period, so how long it will be to see one full sine curve, is 2 pi divided by the frequency of 2, which is pi. Okay, so let's set up our axes. Remember that on the x-axis, every 3 boxes is 30, so we're going to mark off, every 90. And on the y-axis, every 2 boxes is 1 unit. And we're going to go so high as to have an amplitude of 3. Okay, so let's think about what sine normally looks like. So I'm just going to do a little sketch off to the side here. Sine normally looks like that, approximately. That's kind of a rough sketch, oscillating between 1 and -1. But instead of oscillating between 1 and -1, like we said, it's going to start at 0 and go up to 3. Now, in the normal graph, it hits 1 at pi over 2, then comes down to 0 at pi, comes down to -1 at 3 pi over 2, and then ends at 0 at 2 pi. So instead of this graph being one of them from 0 to 2 pi, I have to fit 2 of them in there. So I'm actually going to take this graph, and really the distances along the x, and I'm going to half everything. So what I mean by that is, instead of coming up to 3 at pi over 2, it's going to happen at really pi over 4, which is halfway between 0 and pi over 2. Instead of hitting 0 at pi, it's going to be at 0 at pi over 2. Okay, so then halfway between pi over 2 and pi, I'm going to come at -3, and then finish at pi with 0. So sketch a nice curve. Okay, and recall that we said that the period of the graph would be pi, and that's what you're seeing here. I have one full sine curve between 0 and pi. Okay, so let's do another one. So halfway between pi and 3 pi over 2, I'm going to go back up to 3. At 0, I'm at 3 pi over 2. Halfway between, I'm now at -3. And then finishing at 2 pi. Okay, and I'm going to label my graph. Okay, and it's nice to do a good visual check here. Does it look like my graph is, first of all, sine? Yes, this is a sine curve. Does the amplitude look like it's 3? Yes. From the midline, I'm going up 3 units to get to a max. And lastly, does it look like I have 2 full sine curves between 0 and 2 pi? And that I do. So then the last couple of questions here, the domain. Well, they gave me the domain they wanted me to graph it on. So 0 to 2 pi. And the range, because I'm oscillating between -3 and 3, that is my range. So then the question is, how many curves for the graph above would you see on the interval of 6 pi to 7 pi? And as you can tell, we don't have it graphed that far. We only stop at 2 pi. So the question really is, well, how long is this interval? Well, the difference between 6 pi and 7 pi is pi units. So how many curves, so here's one curve, would you expect to see over pi units? Well, this really refers to the idea that, well, the period of the graph is pi. So you will see one full curve over pi units. So that's your answer. Okay, what is the equation of the midline? Remember, that's this line that goes right through the middle of the graph. That's the line that is really the graph is oscillating about, and that's just our x-axis, or y equals 0. Okay, so on the next page, we're going to do another example where I'm graphing y equals 2 cosine 1/2 x. So first of all, the amplitude is 2. That's the coefficient there. The frequency is 1/2, which means the period is 2 pi divided by 1/2, or 4 pi. So that means if I want to see one full cosine curve here, I would have to graph 4 pi units. So let's set up our axes here. So up here, I'm just going to sketch what cosine looks like normally, so you guys know where I'm coming from here. Okay, cosine normally looks something like that, between 0 and 2 pi. And it crosses the x-axis at pi over 2 and 3 pi over 2, which means it hits this minimum at pi. Now, if we look at the frequency, with it being 1/2, that means that I'm going to see half of the cosine curve between 0 and 2 pi as opposed to one full curve. So really, I'm only seeing, if I box it off here in pink, that much of the graph. So when I graph this, that's what it'll kind of look like, this nice little like slide looking shape here. So half of the cosine curve. So with an amplitude of 2, I'm going to start up here at 2. Now you'll see that normally I cross the graph, or cross the x-axis I should say, at pi over 2, but since I'm essentially taking this and stretching it, I'm really doubling the distance here as opposed to halving it like I did in the last example. So instead of crossing the x-axis of pi over 2, it's actually crossing at pi. And then same thing with 3 pi over 2, or excuse me, with pi. If I'm hitting a minimum down here at -2, I'm really only hitting it over here. I'm actually hitting it over here at 2 pi. Because I'm doubling that distance with it normally occurring at pi. So I realize that this kind of looks like a line here if we were to connect it, but don't make it look like a line. It is half of the cosine curve. So it should look something like that. Okay, so the domain that I graphed on is 0 to 2 pi. And the range is between -2 and 2, based on the amplitude. So how many curves would you expect to see on the interval of -2 pi to 2 pi? Okay, again, we'll think, well, how many units is that? Well, between -2 pi and 2 pi, that's a 4 pi distance. And as we know from above, 4 pi is the period of the graph. So if we were to look down the line, or actually I should say if I were to graph this part over here on the left, you'd expect to see one curve. And that's again because the period is 4 pi. And you need 4 pi units in order to see one curve. Okay, the equation of the midline is still our x-axis in this case, so y equals 0. Okay, so down here at number 3, we're going to be doing two graphs. Y equals -4 cosine 2x and y equals 2 sine 1/2 x. And we're going to graph it on the interval -2 pi to 2 pi. So let's take a second and just set up our axes first. Okay, so I'm all set up. Now let's graph this in pink. So I'm going to do 2 different colors here. So let's talk about some information about this graph before I graph it. Well, the 4 tells me that it has an amplitude of 4. The 2 is my frequency. So 2 full cosine curves will occur between 0 and 2 pi. So we should see one graph or one cycle of it over pi units. So I'm just going to sketch lightly over here what cosine looks like. So it normally looks like that. Now keep in mind, it's also been reflected in the x-axis, which is really important. So normally cosine starts at 1 here, but actually I have an amplitude of 4, but then I'm reflected in the x-axis. So I'm actually starting down here at -4. Now, since this is going to be 2 cosine curves between 0 and 2 pi, I'm like taking this and essentially squeezing it. So it'll look like that. Oops, that's a sine curve. Not like that. It'll look like this. All over the interval from 0 to 2 pi. So instead of crossing at 0 at pi over 2, I'm going to hit the x-axis at pi over 4 instead. Okay, at pi over 2 now, I'm going to be at 4. Come back down halfway between pi over 2 and pi, and finish down here at -4. Oops, -4 at pi. So I'm just going to sketch one curve so far. Okay, so just as I anticipated, I have one full cosine curve occurring from 0 to pi, which as it should because the period is pi. So I'm going to do another curve here. Okay, and now there's your 2 cosine curves. Okay, so it's similar to what I said it would look like, except it's been reflected in the x-axis. Okay, so now I got to do it in the negative direction too. So going back to the left, now cosine is what's the word I'm looking for? Cosine is symmetric with the with the y-axis. So that means I'm going to be at 0, halfway between 0 and -pi over 2. Up to 4, 0, finish at -4. Okay, these look super skinny. I'm going to fix that. Okay, and then keep continuing the pattern. It's a little bit harder to make it look nice on a tablet, but you guys shouldn't have too much of a problem with the pencil or pen. There we go. Okay, so here is y equals -4 cosine 2x in pink. So a nice little visual check. Does it have an amplitude of 4? Yes. Did I reflect in the x-axis? I did, yes. And are 2 full cosine curves occurring between 0 and 2 pi? Yes. 1, 2. Okay, so then the second one, which I will do in purple, is y equals 2 sine 1/2 x. So 2 means there's an amplitude of 2, and the frequency is 1/2. So that means the period will be 4 pi. That's how long it will take to have one curve. Now, if I sketch over here what sine normally looks like that, right? But since the frequency is 1/2, I'm really only looking at half of the curve. So when I graph it, I'm really only going to see this on the right-hand side of the y-axis. So I'm going to take each of the distances that normally occur along the x-axis, or each of those intercepts, and I'm going to multiply them by 2, because I'm really taking this and I'm stretching it. So I'm still starting at 0, but instead of coming up to, in this case, 2 at pi over 2, I'm doubling that distance and it's happening at pi. Then I'm going to come down to 0 at 2 pi. So just as I said, there's the part that you are going to see, half of the sine curve. So then I got to do the same thing in the other direction. Okay, at negative pi, I'm going to be at negative 2. And then I'm finishing at 0 at negative 2 pi. Okay, so label it y equals 2 sine 1/2 x. And as you can see, this is a sine curve with an amplitude of 2 because it's oscillating between 2 and negative 2. And I'm only seeing 1/2 of the graph on the left-hand side, or excuse me, on the right-hand side of this graph on the y-axis. Also, you're seeing one full sine curve over a total of 4 pi units because it's from negative 2 pi to 2 pi. So the follow-up question here is, well, how many times do these two graphs equal each other? So really this is looking for how many times do they intersect. But be careful, they gave you a domain other than negative 2 pi to 2 pi. It says negative pi to pi. So I'm actually going to just put in a little line here so you know where I'm looking. Here's negative pi. And here's pi. So look at how many times those graphs intersect. And that's what's really nice about using two different colors here, is that I can see where the pink and purple intersect. Here's 1, 2, 3, 4. So how many times do they equal each other on this interval? 4 times. Okay, so at this point now we know amplitude, which changes the height of the graph, and we now know frequency, so how many times that it's going to occur, or one curve will occur between, or how many curves will happen between 0 and 2 pi, and period, which is how long it takes for one curve to occur.